Okay, Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So this is part 2 for lecture of chapter 10, scheduling for subject production and operation management. Okay, so I proceed to the next calculation part of scheduling, which is we will go through the Johnson's rule. Okay, so Johnson's rule is sequencing n job onto machines by using the Johnson rules. So it's work with two or more jobs that pass through the same two machines or work centers. So the objective of this problem is to minimize the total production time and idle time. So this is the figure represent the sequences of n job on two machines. So you can see that inputs coming and then go through the machine one, and then it process the input, and then the next one is you need to go to the machine two and then process and then to the output. Okay, so we will look at this example. So before that, this is the list of steps required to solve these problems. So the first one is we list all jobs and time for each work center, and then we choose the job with the shortest activity times. If that time is in the first work center, we need to schedule the job first. And then if it is in the second work center, we need to schedule the job last. So once a job is scheduled, we eliminate from the list, and then we repeat the step 2 and 3 working towards the center of the sequence. So we will look at this example. Okay, so this is the list of the jobs needed to complete by using work center 1 and work center 2. So we have 5 jobs A, B, C, D, and E. So this job must go through this process, these two process, okay, of productions. So the first process is by drill pressing, and then the second process is lathe. So how can we sequence the job? Okay, so we will look into this number. Okay, we have center 1 and center 2. So to sequence the job, we need to look at this first. Okay, we need to look at this value first, and then from the step is say that to find the shortest time. So between this all of this time, okay, which is the shortest? 2 is the shortest, and then 2 is in the work center 2. Okay, so the smallest value come from the second center. So from the list of step here, it say that if the time, okay, come from the second work center, we need to schedule the job last. Okay, remember we have 5 jobs. So this is the sequence that you need to do. So please do the table like this to fill up the job so that you won't forget. Okay, you won't miss any job. So back to the first one. So this is the minimum value from this one. 2 is the shortest time. So 2 is from machine 2. So if the time lies in the machine 2, we need to sequence the job last. So that means that we need to put a last sequence. Okay, then we cancel out this part. So now we still have 4 to go. Okay, still have 4 to go. And then again, we need to look at this part. So which is the shortest one? 3 is the shortest. So 3 is coming from work center 1. Okay, so work center 1, if the times come from the first work center, we need to schedule the job first. Okay, so 3 come from the first work center, so we need to schedule B first. So we put this on the first box here. Okay, so we cancel out this. And then this left. Okay, this is left. What left now? So 8, 4, 10, 7, 7, 7. This is the next shortest. So come from work center 2. Where do we need to put this C? Last box. Okay, from these 3 remaining, so this is the last box. So we need to put C last. So we cancel out this. So now we have another 2 jobs. So we have 7 and 7. It doesn't matter if you want to take which is the first smallest. So let's say we take D here. So 7 come from machine 2. So we need to put D on last remaining 2 box here. Okay. So this is D. And then E is the remaining box. So the sequence of job is B, E, D, C, A. Okay, B, E, D, C, A. So now we need to calculate the total times of production. Okay, it's coming from the workstation 1 and then workstation 2. So it start at 0. Okay, so this is the time. This is the, so if you see here, so this is how we sequence the job. Okay, now we want to solve the problems. Okay, solve the problems coming from this. Okay, so we have timeline. We have timeline for this part. Okay, we have timeline. So starting from 0 up until the end, we don't know yet. So this is the objective, to minimize the time of production. So we will do machine 1 first. So every job A, B, C, D, E need to undergo into machine 1 first. So it's you need to do one by one. So A, we have A here. Okay, A is coming from 0. How does it looks like? Let me see. Okay, 0. Okay, again, workstation 1. Sorry, not A, but B. So this is our sequence, B, E, D, C, A. So we need to put the job B first. Okay, so B coming first. So the working time starting at 0 hours. So let's say this is represent in hours. Okay, so starting 0. So we put B in the machines. So B in the machine 1 required how many hours? From the table here. Sorry. Okay, so B for machine 1. Okay, so you need to process B in machine 1. So the time required is 3 hours. So this is time required. So 0 until 3. So you start at 0 hour. So you will finish at hours 3 after that. Okay. So after finish B, and then we need to process E immediately after B finish. So we need to fill E in the machine. Okay, the job E. So what is the time required in machine 1? For E is 7. So 7 plus 3 is 10 hours. So E process starting at hours 3, and then the time required is 7 hours. So the E still in the machine up until 7 hours. So 3 plus 7, so it's finished by hours 10. Okay, after we finish E, we need to process D. So D put in the machine, and then the time required for D is 10 hours. So this start processing at hour 10. So it will finish processing D in machine 1 at hours 10 plus 10, which is hours 20. After we've processed D, finished D, we put C in the machine, and then C required 8 hours. So start at hours 20. So it will finish at hour 28. And then the last job is A. So A the required time is 5 hours to process. So you will finish processing A in machine 1 by hour 28 plus 5, 33 hours. Hour 33. Okay, so we done for work center 1. Now we go to the work center 2. So when one job finish process in machine 1, so it will immediately transfer to machine 2. So we want to process same sequence for machine 2. So we want to process B first. Can we start B at 0 for machine 2? Can we start it at 0 for machine 2? B. Cannot. Okay, we cannot start at 0 because at 0, B still in process inside the machine 1. So we need to wait until B finish process in machine 1, which is at hour 3. So after finish at hour 3, immediately we can transfer to workstation 2. So that's mean for workstation 2, okay, it start at hour 3, not hour 0. So 0 until 3, the machine being idle. Okay, we're not using machine 2 from 0 until 3 because B is still in the process in machine 1. So it start processing B at hours 3. So what time required for B in machine 2, which is 6. So 6 hours processing time. So 3 plus 6. So B can finish at hours 9 in machine B or workstation 2. Okay, now we need to process E. So we need to check whether at hours 9, E already finished process in machine 1 or workstation 1. So we look here, E, the processing finished at hour 10. So 9, can we start doing E at hour 9? Cannot. Okay, cannot. The answer is cannot because E is still in the machine 1 at hour 9. And then E finish at hour 10. So we cannot process E at hour 9. So we need to wait until hour 10, then we can process E. Okay, so E, what is the requirement time of processing in machine 2 is 12 hours. So 10 plus 12 is 22 hours. So E finish process in machine workstation 2 at hour 22. Now we need to process D. So we need to check, is D already finished in workstation 1? So you see D finish at hour 20. So here is hour 22 already. So can we start immediately processing D? Yes, because D is already finished in workstation 1 by the time 22 hours come. So we start immediately process D here. So D required 7 hours. So 22 plus 7 is 29. And then same step, we need to process C. So first need to check in workstation 1, C finish at what hour? So 28 hours. So this one, by this 29 hours, C is already done at 28 hours. So we can start process C immediately. So C required 4 hours. So 29 plus 4 is 33. Okay, now after C finish, we need to process A. So A in machine 1 finish at hour 33. So here is also 33. So we can start immediately process A at hour 33. And then the time required is 2. So the total time would be 35 hours. So that means we can conclude that the total time of production is equal to 35 hours. Okay, so 35 hours is the total production time if you use the Johnson rules. Okay, if you're not using Johnson rules, okay, so you can see that without Johnson rule, so the total hour is more than 35. With Johnson rule, we already short the time to 35 hours only. So that's why we need to use the Johnson rule to solve these production problems. Okay, so this is like the answer, final answer. You can see here. So this is the same step as what I did before. Okay, so this is the same step as what I did before. Okay, so I summarize this in a table so that you can see the time here. So you start 0 up until 5. So this is what I mean, okay, by the time being idle. Okay, here, sorry, with Johnson rule, this is idle time. Machine 2 is not functions at hour 0 up until 3 because we need to wait B finish first. So when B finish, then we can start process B in machine 2. Okay, same goes to E here. So when you finish B at this hour, so you cannot start immediately processing E because E is still in the processing from machine 1. So E finish here, then you can start process E. Okay, and then D finish here, so that's why you process immediately here. C finish before D finish, so you can start process C and A also. So this is how you solve the Johnson's rule. Okay, so you can try do it this example by your own self. Okay, and then the next one is the employee scheduling. So here is we need to solve the problems related to the employee scheduling. So we want to make sure we meet the requirements. Okay, so that's part that's part here. Okay, I will touch on the next class. Thank you.